In this video, I will demonstrate DELDroid, a system for automatically determining and enforcing the least privilege architecture in Android. Let's take a look at the research problem that DELDroid addresses. There are two types of privilege a component can have. Communication privilege, in which a component can communicate with other components in the same app or in a different app. Resource access privilege, in which a component can access the system resources such as location service, telephony service, etc. The system resources are protected by system permissions. Android grants these privileges at the granularity of apps, so all components in an app inherit the same privilege. Therefore, almost all components are overprivileged and hence violate the principle of least privilege. This violation is the root cause for many security vulnerabilities, such as privilege escalation, information leakage, intent spoofing, and intent hijacking. To address this problem, we have developed DELDroid, which derives the least privilege architecture from the app's bytecode, analyzes the security posture of the system, and enforces the established architecture at runtime. Moreover, DELDroid allows a security architect to adapt the architecture while the system is running. Our approach consists of 5 steps to determine the least privilege architecture and enforces it using the privilege manager layer, which is a new layer that we have added to the Android framework with the ability for the security architect to change and reinforces the architecture while the system is running. DELDroid captures the least privilege architecture as a set of event condition action and stores them in the ECA rules. I will use an Android system with two applications. Social application that allows you to post tweet to your Twitter account. This application consists of two components, compose tweet activity and post tweet service. ICC attacker is a malicious application that performs ICC attacks to leak the device ID and the phone number through the user's Twitter account. Hidden activity uses dynamic class loading to communicate with post tweet. Explicit activity uses explicit intent to communicate with post tweet, whereas implicit activity uses implicit intent to perform the ICC attack. In all of these cases, the device ID and the phone number are obtained by accessing the telephony service, which is protected by a phone permission. Now, Architecture Manager is an application that provides graphical user interface to the privilege manager layer. As you can see, the ECA rules repository initially is empty. Now let's generate the least privilege architecture for this Android system. As you can see, DELDroid generated the least privilege architecture and enforced it in this device. These are the ECA rules that capture the determined least privilege architecture. Now let's take a look at the generated least privilege architecture. So here is the determined and enforced least privilege architecture. Number 1 here means attacker main can communicate with component number 2, which is explicit activity, this communication. Now this architecture shows us that the hidden activity is not allowed to communicate with post tweet. That means the ICC attack performed by hidden activity is already prevented by applying the least privilege architecture. So hidden activity will not be able to post a tweet to the user's Twitter account. As you can see also from the architecture that explicit activity communicates with post tweet using explicit intent, number 1, and implicit activity can communicate with post tweet service using implicit intent. These two components also are using the phone permission. That means the cat can obtain a handler to the system resources that are protected by the phone permission, which is in this case telephony service. Now let's prevent these two components from accessing the telephony service and reinforce this architecture. So now the new architecture has been enforced and has been enforced at runtime. As you can see that the explicit activity and implicit activity, both of them will be able to communicate with both suite, but they will not be able to leak the device ID and the phone number. As you can see here, they return null. Okay, now let's prevent these two components from communicating with component number 5, that is the post suite, and reinforce the new architecture. Okay, now I see now explicit activity cannot communicate with post suite nor implicit activity. Note that not only the inter-application communication can be prevented using DELDroid, but also the intra-application communication. Like for example, we can prevent attacker main from communicating with the hidden activity and reinforce this architecture. As you can see, the main activity is not cannot communicate with the hidden attack.